everybody. Works? Yeah? Okay. My name is Jacques Desbiens. I'd like to bring to you some observation on synthetic holography. This is, in fact, a follow-up of my presentation that I made in Shenzhen in 2009. You were not at Shenzhen? Well, shame on you. You missed something. Basically, I use the term synthetic holography because I want to differentiate from digital holography. To me, digital holography is generating from data a fringe pattern. While synthetic holography, it's a word that I started using with people from computer graphics, and they knew already what I was talking about because they used to use synthetic images for computer graphic images. So I thought it's a good way to name what we call holographic stereograms, holographic panoramograms, computer-generated holograms. Basically, it's simple. It's a set of many images that you use to make an hologram. Now, I should point out that I don't have a scientific background. I have a very thin experience with analog holography. I come from perspective. I'm an art historian. I draw a lot, but I've never had any courses on drawing. I read books, look at art, and then in the 80s, I had this doubts about many things in art, and I thought, okay, I have to test. So I start experimentating. So I'm an art historian who does experimentations, which is very rare in the art field, in the art history field. So I've always worked with optics and geometry, and I'm a specialist of perspective, spatial representations, and I end up in 1998 working with a team to develop a large format, full color holographic imager. The company was called XYZ Imaging, and we developed this machine in collaboration with Geola. So you may know this technology under the name of the Geola printer or rabbit hole printer, which recently was sold to STM Holographics in Toronto. I left in 2004 and continue making my experiments. What I was doing there was image quality analysis. I would make a few images on my computer, print them, and then put them on a wall using a spectrometer, different tools, CCD camera, and make analysis of MTF, distortion chart, color chart, and all that. It gave me a very hands-on experience on what was the image there and what I could do with this. So I left, and then I continue making some experiments. But since I like history, you'll notice in what I will show that I use my research in the history of art and science as a content and as a way to bring a little more information in my holograms. I could do geometric stuff or abstract stuff, but for me, there's no real difference. So I use a lot of history. So let's start with a few points from history. Late 19th century, Etienne Jules Marais, excuse me, used chronophotography. He's simply taking a lot of photographs very fast of something moving in front of him. And use this to analyze movement. Later in his life, an interviewer asked him how it feels to be a pioneer in cinema, and he didn't like the question. He said, I have nothing to do with cinema. I never wanted to reconstruct movement. I just want to decompose it and analyze it. For many of you, this is an important guy because he wrote a book called The Graphical Method. So when you use an histogram, when you use photography, when you use holography to analyze something, he's your father. A bit later, the Lumière brothers. So I was saying that a few years after, the Lumière brothers take Maré's idea and use the same kind of set of image, of divisions of time. In fact, they are taking the movement and making a lot of image of that movement. And they invent the cinematograph, and they have the first movie. But notice something. On this image, the camera is dead center. It doesn't move. Everything moves inside the image. What the Lumière brothers are doing is that they're using photography. For them, it's just photography with movement. It's still borrowing from another medium. So they send their cameramen all over Europe and ask them to film cities. So they send Alexandre Promio to Venice, and he has this very nice idea. He puts his camera on a gondola and starts filming a canal. So here you have the first traveling shot in history. And usually we say that Lumière invented the cinematograph and Georges Méliès invented cinema because Méliès invented special effects. But in fact, Promio makes the first narrative tool that belongs specifically to cinema. Lumière borrows from photography, Méliès borrows from theater, and Promio does something that no other technology can do at that moment. So I would open a little parenthesis and say, you have there the start of the cinematographic language. And then a few years after, another trick is adopted, and another one is invented, and another one. And it continues after more than 100 years. You have cinematographic languages developed. So frankly, how can we ask holography to arrive after a few 50 years of development to have a full set of holographic language and be full grown artworks? We are just beginning, in fact, to develop those things. And what I think is interesting here is that they're using, in fact, a concept called fragmentation, a set of many images to bring a new kind of image. And this concept, I think, was very interesting to me. So I'd like to go even farther in history and bring you a quotation from Francesco Maria Grimaldi. He wrote an optics treatise in 1665 called Physics and Mathematics of Light, Color, and Iridations. For you, I would say that this guy is very important because he's the first one in history who used the word diffraction. He says a fourth lighting method is known here, and now I propose to name it diffraction. First time you have this word. And his definition of diffraction is very interesting. At certain moments, light is divided, being partitioned, multiplied, sectioned, and separated. I would say that with our modern eyes, this is a very simplistic definition. Ours is maybe more complex, but if you think about it, it's still valid, it's still true, maybe incomplete, but it's still true. So I thought that this, at that time when I read this, I was working on the development of the holographic imager. And I was thinking about how many times we are breaking up the images and the content. So I thought about fragmentation, and I thought there is many levels. We have In synthetic holography, you start by dividing your field of view. You're in your computer graphic program, and then you set up your camera, virtual camera, and you take one image and another and another and another, and you have 1,000 and more images of your whole field of view. And then you fragment a little bit more because it was a direct write system. So we use an algorithm to break up group of images, recombine them to make new images that fit the optical system of the holographic imager. You also have a fragmentation of the image in 3 channels, red, green, and blue. You have a fragmentation of the hologram itself by making thousands of little holographic cells, or holopixel, or holographic pixel, or hogels, whatever you want to call them. I call them cells. And then to make your hologram of these cells, you use diffraction as it was defined by Grimaldi, so fragmentation of light. So I thought, with that much level of fragmentation, maybe you have fragmentation of content also, so fragmentation of narration. The way you will bring your information in your hologram may be fragmented too. So I decided to do an experiment. So 2005, I made the Tractatus holographic. For me, it's an experimental hologram. I wanted to check something, but I decided to use a subject related to history. So I made a fictitious treatise on holography that would be written in the 17th century. So it's like a perspective treatise, in fact, but 3D images, 3D illustrations that moves when the observer walks in front of it. And I divided my field of view into 3 parts. From the left part of the field of view, you see 2 pages. From the right part of the field of view, you see 2 other images, and the center is just kept for the page to turn. So that, to me, that was showing something, is that I can already double the content of information in my hologram by dividing my, field of view. And I had this big time smear in the middle. And I remember when I arrived and look at it, I said, oh, no, that's a big defect. And people start to say, everybody, in fact, in the lab and after when I said, oh, I love this big blurry thing in the middle. So, okay. So in 2009, just a few months after Shenzhen, I decided to push a little further this experiment. And I made another hologram, which you have a smaller version exhibited in the M.I.T. museum. So tonight you will see it. It's 1.5 meter large by 30 centimeter, and it's a smaller version because the original one is 30 centimeter, 3 meter, excuse me, 3 meter by 60. I've never exhibited the big one. Nobody wants it. It's too big. We worked, it was so important at XYZ Imaging that we make large size holograms. Nobody wants it. Anyway, you have here 3 images of that hologram. That's one hologram, but 3 different compositions. And from the left of the field, part of the field of view, you see like a blurry landscape with a mountain and some calligraphy on top of it. In the middle, you see books, paper, drawings, images, and calligraphy. And the last part on the right, you have water, the books slowly disappear, and you have also calligraphy. So this one is different from Tractatus holographis who change radically from two page to two other page. In this one, every parts of it, every object, every form is independent from each other. So even though you have three main compositions that changed one to the other, it doesn't follow the same rhythm. It doesn't follow the same timeline, I would say. You have some objects that start to transform, others at a bit later, others before. So it's very, very chaotic. And my idea was that you have to look at how people observe hologram. And its perception by itself is chaotic. Observation is even more chaotic. People go left, they go right, they reverse, they go in front, behind, they stop, they go slowly, fast. You have absolutely no control on that. So instead of doing something ordered like the Tractatus, which I know that people will follow a certain order because there's a text, well, most people go from page 3 and 4 and then 1 and 2, so who cares? Why not fit this chaos of observation? So it's an hologram that goes all the way around. And I brought some in this text about in Chinese, in Arabic, Renaissance French, Latin, Greek, and Italian. I know that maybe somebody, I don't know this person, but I know that most people won't be able to understand what's going on there. And to interpret everything. So this is not important. So already? Okay, so I use here 5 minutes. Yeah, I'd like, I will try. Okay, so you have many tricks here that use superposition, alignment, and different ways to bring content. For example, this text talks about the invention of writing by Kanji, which is a mythical Chinese character who looks at animal tracks and decide to make little drawings that describe objects. When you move, you will have some bird tracks that will appear behind on the surface of holograms. From another part, you will have a Arabic text on the research and experimental methodology. And in front of it, a drawing by M.I.T, which is an important character in the history of optics. And this drawing is the first correct description of stereoscopic vision. And when you look at the hologram, the video, you will notice that the transformations between all those scenes adopt some kind of wavy movement. It's like a wave. That is not computer graphics. In fact, it is time smear. It's a form of an effect of time smear, which is a distortion here. Most of you don't like time smear. It's a defect. But this, I think, is a very interesting tool in narration with holography. So I added Leonardo da Vinci drawing on the interference pattern. And here I made a calligraphy that when you move just a little bit, it makes the big, colorful swirl. So I'd like to conclude with the last one. It takes a minute. One of this way of bringing narration I used is that you have a mountain at one point, and when you move, this mountain transforms into a calligraphy that keeps the shape of the mountain. And this text to me is very important. It's from Kuo-si, who is a Chinese painter of the 12th century, who was very interested in how we represent space. And this text that you have on the left bring a few things that I think is very interesting. He described the variation of distance when you look at the mountain as the change of shape with every step one takes. And he also says that when you vary your point of view, you have different shape of a mountain as seen from every side. And then he concludes by saying a single mountain combines in itself several thousand appearances. Here you have fragmentation again, several thousand appearances. And you also have in the change of shape with every step one takes, content metamorphosis. That things change when we change point of views. And I think this applies perfectly to synthetic holography. And I would conclude like he did, should we not realize that fact? Thank you.